welcome. So today, my name is Philipp Landgraf. I'm head of tech at Holo-Light. And with me, it's really great to have him here, is a colleague of mine from Deutsche Telekom. He's senior director for XR and Metaverse, Terry. What we want to talk about today is how do we roll out enterprise XR solutions. And we will use streaming and 5G networks for that. Because if we look to the industry today, this is where we are. We have a lot of great use cases. I mean, I'm coming to the AWE since 4 years, of course, with a COVID break, but I always see such great use cases. They look stunning. You see the value it would bring to industries. But somehow, we are still in laboratory environments. So we have some innovation happening at companies. We have innovation managers using it. But where we want to go is that. We want to come to a world where XR is used in everyday life, where you're through whole companies rolled out, that every worker there uses it and has it. And it's not only some small use cases in small innovation departments. But why are we not here? We have this great tech, but somehow it is quite hard to roll them out. And I will tell you, the first issue you run into is the data complexity. Because when you do a POC, you know the data, you can prepare it, you can make it look nice, you can make it working quite easily. But as soon as you want to use it in everyday's life, in production, you can't know the data before. You can't have a huge process to get the data in. So it is really important that the data works as it is there, as it comes out of PLM system, as it comes out of, for example, MRT scans, depending on which industry. But every industry faces this issue. Works great with made-up small POCs, but it's really hard to get working with the real thing. Another thing is data security. We are still at data, and especially for us in the beginning, a lot of companies were like, yeah, we want to have the use case. We want to use it, but you are not allowed to put our data on mobile devices, which makes it really hard. But it also makes sense because the data is really sensitive. They have so much security measures in place just that they don't lose the data. And we would put it on mobile devices, which can get lost, and then everybody has it, or the data is out. So it's understandable why this is an issue, but of course, it's hard to come by. A third one is visual fidelity. When you start with XR, the first use case was, hey, I can show stuff without bringing it. I can show you a car exactly how you want to have it without actually bringing it here. And these were among the first use cases, but never really took off. Because if you have to render everything on these devices, I think most of you know, it's not like it looks photorealistic yet. And the fourth thing, as soon as you want to be rolled out, is availability. The app, or in general, the whole ecosystem, has to be available all time, everywhere. And that is, of course, necessary. Like if you are in production and not in a POC-like environment, and it like crashes and you can't use it for 1 day or even only 1 hour, production holds. That can't happen. So this is a really crucial point. And I think we solved these issues. We are at a point where we can do rollouts. How? We have something we call ISAR. This is a streaming technology which streams everything from the device to a server. And every rendering, every heavy lifting is happening on servers, either on-prem or in data centers or in cloud. So it depends on the companies. You can, of course, have everything in cloud, but it also can operate without any internet and darknets, which is quite important in high-security industries. And what we do is quite simple. Instead of having the computation power on the devices, we shift everything to these powerful servers. Showing you that this is already there is I have 3 examples. We are rolled out in more than 100 enterprises with streamed solutions, mostly together with partners. And I want to give you 3 examples. The first one is BMW. BMW, they use it quite a long time already, and they use it for prototyping. So imagine if they build a car, whenever they change something, whenever they want to try out something, they have to build prototypes. And they are crazy expensive, and it takes a long time because you don't have factory bands building prototypes. So imagine every part in every BMW one day was 3D printed, handcrafted, and all this stuff. And sometimes only to find out it doesn't fit in, or it's completely wrong. And that's where they use XR now, because with XR, they can take the data, fit it into the real car, see, does it fit, does it work, does it look like how the designer intended it, and can, for example, do tests. Can I still assemble it when building it in? And that's what they do. And according to BMW, they save a stunning 1 year for each car they develop right now. And of course, also a lot of money, and with that, a lot of environmental resources, because they can just build 30% less prototypes, where they can already find the things they need to do in AR before actually building it. Second example, Engie. What they do is it's also going in the direction of design reviews. So they build huge machines, for example, like cooling aids, and they need to test, do they fit in this room? Do they look like they should? We need to make quality assurance after the whole process, and that's what they use AR for, because it's just much easier than look at a computer, look at the real world, measure it, think about it, does it work, to just display it. I mean, you all know what we use XR for, right? And it's, of course, a really, really cool thing you can do. The last example I want to show you is from a completely different use case. It's not engineering, it's healthcare. But they have similar issues. What NHatch does, NHatch wants to do surgery planning, and they use the data from the patient so they can plan exactly how the surgery will happen. Of course, this also works without XR. But in particular, if you have, for example, 2 different specialists collaborating, everybody knows the part and the surgery parts he does really good. But if they need to collaborate, it becomes difficult. And it's for them much easier to work in 3D, in XR, and plan everything through. And in a couple of years, for sure, this will also help in live surgeries. And why do they need streaming? Exactly the same issues. This data is heavy. An MRT scan is really, really heavy data. There's no way without manual doing before to display it on a mobile XR device. And they have to be mobile. You can't be wired in a surgery room. That doesn't work. And that's what they use streaming for. And I told you, the issues, we solved them. Let's start with them. Why do we solve them? How do we solve them? The data complexity. That is quite easy. Data complexity, we can now use really powerful rendering servers instead of these watered-down mobile devices. You can really imagine, instead of, let's use the example of a HoloLens. Instead of use this small, tiny HoloLens computer, we can use server farms with RTX GPUs. Of course, that solves our issue, because whatever you can render or use on a computer, we can now use in mobile XR. Data security, it is quite even easier solved. In data security, what does happen is the data never touches the mobile device. So I can even log in, I can review the newest BMW, you steal my HoloLens, you don't have anything. Because the data never has been on there. Even if you're the best scientist, getting data off this hard drive doesn't help you. All you got was always the image stream of the running app. And coming to the last point here, visual fidelity, same issue. You have just much more power. If you look at the demos, the great things a Unity engine, an Unreal engine can do on high-power computers, that goes close to photorealistic, or even so good that some people can't say, is this real or not? And imagine you can now use this on mobile XR devices. It gives you a lot more opportunities, a lot more things you can do. And this breaks the issues you have. And this makes you able to scale out in enterprises because the issues are solved. But these were not all. I forgot one, or I didn't forget it. but this is not what we do. Availability. For availability, we work together with partner companies because we are a software company. We are a technology company for software technology. We can't provide infrastructure. And for that, we work together with AWS and Telekom, AWS for the server powers, Deutsche Telekom for the 5G cellular networks. And now Terry will show you some really cool new things which make something really good even better. And we are talking here about streaming in cellular networks. Yeah. So Terry, go ahead.
Cool, thank you very much. So hi everybody. So I'm Terry Schussler. I focus on 5G, edge computing, AI, XR technology intersections, and I've been kind of known at Deutsche Telekom as the XR glasses guy. I'm not wearing glasses because I wanted you to see the AR content. So really the first thing I wanted to do is talk a little bit about what is the most critical part of a good user experience with streaming XR content is addressing the concerns of latency, right? So this is the amount of time it takes for data to go from the user's device to the network and come back with a response. And in the past, we've built mobile apps for over a decade where we just kind of accept whatever the network gives us in terms of performance, and often design and engineer the applications to the common denominator experience that we get in our QA processes. And that doesn't really create the elevated user experience that's possible when somebody has a 5G connection, has better connectivity, has lower latency. So what we're really been focusing on in the last few years as we've launched 5G is how can we optimize the network performance for XR use cases, especially for data and functionally intensive enterprise use cases. So, what are the types of use cases that are really important to be concerning yourself about with latency? So most of them are enterprise use cases. There, of course, are things like cloud gaming, but we have generally two sort of classes of use cases. One where we're actually offloading the compute to the network. And here, we talk about remote rendering applications. We're computing an image of something that's not possible to do on device, right? We can't render a 50 million polygon 3D scene on a HoloLens 2 or Magic Leap 2. They're just not capable of that kind of compute level. So we want to create the experience for the user of what this looks like, but we need to do this by utilizing network compute, offloading the functionality to a higher-end GPU performance system and creating a better user experience. The other class of use case, which we typically see, is one where we need to synchronize time and space, basically organizing multi-user experiences where we're synchronizing the content interaction on the network. And you see this in even just multiplayer gaming platforms, but in collaboration platforms where we're doing work in XR, working collaboratively on a real-time 3D object, we need to have the network perform functionality for us to create a synchronization of the user interactions that are occurring with different latency setups, right? Because some people are going to be at different physical places in the world as they're interacting with the same data set, and their latency connecting them to the network is going to be different. And so we need to utilize software to enable that. So the easy way to really think about how we're addressing this is we're doing two things. So one, I'm going to sort of explain this backwards. So one is that we've been working with partners like Ericsson to create new technical standards for how radio operates and how packets of data move through the network from a server to a user's end device, a phone typically, or a head-worn device, and then back. And this optimization that we do inside the radio core creates the most granular place where we can do the work necessary to create an optimum network experience and to address the concerns of not only latency, but also jitter, right? Jitter comes when there's a variable amount of data traffic moving through the network radio and there's congestion. And so when too many people try to connect to one radio, then not everybody gets that smooth flow of data. And that creates an inconsistent user experience. So we want to address both latency and jitter to create an optimum streaming experience for users. And you can think of the result of jitter being dropped frames in a video, right? If you're streaming a video off of a network server and the frame data, the packets of data for that frame don't make it through the radio to the user's edge device fast enough, then the frame data gets ignored, and we skip rendering that frame to the user, and we show the next frame when it shows up, hopefully in time. And then even if that frame doesn't show up in time, we may skip a second frame. And you can see in this example here, we skipped frames 2 and 3 because that data got held up in the radio of the network and didn't get to the user device fast enough. And so this goal that we have is to smooth out the experience for the user. And how do we do this? We do this by understanding what's happening in the radio at the application level. So right now, applications go, hey, server, give me some data. And then the data comes pouring in whenever it happens to show up. And the application has no understanding of what's happening, what to expect, when the data is going to show up next. It just gets what it gets, and it just deals, reactively to it. But instead, what we're really focusing on is creating an intelligent connection between the radio and the application so that the user application can understand when there's congestion on the network and actually measure it and react to it in real time, or near real time. Nothing's real time, but near real time, and create an adjustment on what's happening on the server side so that the flow of data comes down at the proper time. So let's take a little bit more of a visual look of what this kind of means, and I'll pull this image up a little bit bigger so everybody can see it. So you think of in terms of a normal home heating system where you have a central heating unit, you have a radiator, you're feeding hot water to it so you can create heat in a room, and you're using a thermostat to provide some information about what the actual temperature of the room is ambiently, right? So think of it this way. That's the visual, but I'll give you the technical explanation. In the radio, as packets of data go through, there's a feature in the radio called the scheduler. And the scheduler is saying, hey, I've got 20 different applications pulling data through me right now from different servers, and I'm trying to manage the doling out of these packets of data in a fair and equitable manner. But the reality is that it's like real life, right? Where your boss comes to you and says, I need you to do all of these forms now on top of all the other data, and you're like, I don't have the bandwidth to do all of that. That's what happens with the network scheduler. And so it starts to delegate out the packets of data, and it queues up the things that it can't get to in real time into a queue. And as it puts these packets of data in the queue, it actually marks them with a little bit. This bit is called the congestion bit. And this bit of data that's coming down with a packet can be read by an application and analyzed, and we can compute how many packets of data we're getting have congestion bits. And once we know that, we can start to compute what's the expectation that we set for the user experience, and what's the reality that we're getting on the network. And so from this point of view, what we are able to do is we're able to allow the application to send commands back to the server to change the behavior of the server to reflect the reality of the application. And so imagine if you're streaming, a highly rendered video sequence at 60 frames per second and you're targeting 10 megabits per second, you might dial it down to 5 or 3 and let the frames come through faster because we're reducing the number of packets of data that we're using. So this is the general gist of the technology standard called L4S. And L4S basically is going to be a global standard that will be applied by all the telcos. It's co-invented by Deutsche Telekom, but it is not a Deutsche Telekom standard. It's going to be in the US, it's going to be in Canada, it's going to be in Australia, it's going to be in Europe, it's going to be everywhere, because it enables the network to deliver a better XR, dare I say, metaverse experience. And so let me show you, if I could, a little video which illustrates this. And if you look on the left-hand side, you're going to see what the normal experience is with a cloud gaming application. And when you see the graph on the top go up, that means that there's jitter, congestion happening on the network. And you see the frames of video stutter as they get dropped. On the right-hand side, you can see a very consistent flow of data, low jitter, low or consistent latency. And so this is really all about creating a great end user experience. The quality of experience gets elevated when we intelligently operate the data traffic between the server and the end user application utilizing these core network technologies. And that's really going to change the future for a lot of, it's not just for streaming video, but it's also for other applications. Maybe you're pulling blobs of data in the background, queuing up 3D objects that you want to show later time rendered on device, or other media that you need to use to present to the user. So this is the idea that we are focusing on, is how do we enable a wide variety of enterprise use cases which push the bounds here most intensively to deliver a great quality of experience despite variance in network conditions.
Thank you. So, thank you. And how does this now connect to our streaming? This is what you see here. Since we aim to give you the best experience possible in XR, of course, we also integrated L4S in the streaming experience. So if you are in a perfect network, you don't need it. But here's the thing. Usually, in particular, cellular networks are congested. Imagine if several people connect, then whenever this happens, you get short stutters. And that is, of course, what we need to avoid. And with L4S, this is possible. As you see in the video, on the left side, what happens here is that somebody starts to download a huge amount of data from the internet. And whenever he does, the whole network gets so congested that the XR experience stutters sometimes. And by L4S, this was easily solved. So this is where we are today. I showed you we have XR rollouts. You can roll out your applications in huge enterprises worldwide by using streaming and 5G. But where is this heading? And if you think about it, what is also holding XR a bit back? And it's the devices. They are heavy, they are too large. We go in the right direction, but we are not completely there yet. And streaming can help. Imagine, you don't need to have any calculation power in the devices. You can have less battery, and they even last longer because they don't need to do that much. And by that, these XR devices can become really small and nice lifetime objects. And this is what we want to have in the future. We will have a global metaverse where everybody can be connected, can have the app streamed with glass-like small devices. If you want to know more about it, and in particular about the metaverse, which we already have for industry, you can either go on our booth, you can book a private demo. We have an actual multi-user collaborative metaverse experience where you can go together in several applications and experience how the future will be, but it's already there today, and it's already deployed at customers today. And if you also want to know more about the cloud-enabled metaverse, head over to the main stage where my colleague and our COO, Susie Haspinger, is together with AWS talking about how this industrial metaverse works on the AWS cloud. Thank you very much. Let's stay connected. If you have any questions, come to the stage. I'm happy to talk with you. Visit us at our booth. And of course, LinkedIn is a great tool. Let's get connected. Thank you.